It's time! The human heart. Just look at this machine. You remember him, right? Yes, it's WALL-E, the iconic robot who meets Eva and falls in love with her. Have you ever been in love, Yes, I can see it now. 2 soft buns, cheese, tomato, my burger. Oh, Anyways, which organ is associated with love? The heart, right? It's kind of obvious. But the truth is our heart doesn't teach us to love. And most important, it doesn't break apart when somebody leaves us. Yeah, it's true. Our heart, the cone-shaped organ, is actually a complete workaholic. Throughout our lifetime, it tirelessly pumps oxygen and nutrient-rich blood to all of our body parts, just like a pumping machine. Come on now, close your palm and form a fist. Don't worry, I'm not asking you to fight. Our fist is approximately how big our heart is. It is located between our lungs, slightly tilted towards the left side. It is enclosed in a double-layered sac called pericardium. Does it taste like peri-peri fries? No, What does a picture frame do? It holds the picture in place, right? Without the frame, the picture would fall off. Just like that, the pericardium protects the heart by anchoring it to the surrounding tissue so that the heart stays in place. Pericardium also prevents the heart from overfilling. Now, just like Captain America's shield is made of special alloy, our heart is made of special muscle cells called cardiac muscle fibers. Now, let's dive in. Just like a tennis net divides the tennis court into 2 parts, the heart is also divided onto the left and the right side of a wall called cardiac septum. The right side of the heart is filled with deoxygenated blood, while the left side is filled with oxygenated blood. And this dividing wall prevents the blood from mixing. Each side of the heart further divides into 2 chambers. The upper chambers are called atria, while the lower chambers are called ventricles. Where are the sleeping chambers? Stop it, Let's first learn about atrium. Now, just like a postbox receives letters from multiple people, the atrium receives blood from different parts of the body. Thus, the atria are simply receiving chambers. They have thin muscular walls. Why thin? Do they believe in size 0? No, Their walls are thin, not requiring a lot of muscle tissue, because they only have to pump blood into the ventricles present right below them. Now, moving on to the ventricle. Just like the postman collects all the letters from the postbox and delivers them to their respective locations, ventricle also collects blood from the atrium and pumps it to different parts of the body. Thus, the ventricles are called discharging chambers. Just like coconuts have thick outer covering, ventricles have thick muscular walls. Why thick? Because the walls need more muscle tissue to generate enough pressure so as to pump blood out of the heart and distribute it to the entire body. Now, the left ventricle's wall is even more thicker than right ventricle's wall, because the right ventricle pumps blood only to the lungs, while the left ventricle has to pump it to the entire body, requiring much more pressure than the right ventricle. Now, let's talk about the valves of the heart. In total, we have 4 valves: tricuspid valve, bicuspid valve, pulmonary valve, and aortic valve. What happens when you hop onto a flight? Can you just change your mind and ask the pilot to turn back?
Oh no!
Nope. Same with the 4 valves of the heart. They are fibrous flaps of tissue allowing the blood to flow in one direction only, and then they close tightly, preventing the backflow of blood. So they basically act like security guards. The tricuspid valve guards the opening between right atrium and right ventricle, while the bicuspid valve guards the opening between left atrium and left ventricle. Together, they are called atrioventricular valves. Pulmonary valve guards opening between the right ventricle and the pulmonary artery, while aortic valve guards opening between left ventricle and aorta. Together, they are called semilunar valves. atrioventricular, semi-lunar, sounds like the names of some Star Trek guys. Oh, some. So that was all for the structure of the heart. Now, let's understand its working. But before that, let me ask you something. Why is the heart so important? Can't we survive without it? Depends. Can you survive without oxygen? No, right? Who is the guy making sure that every cell of our body gets oxygen? The heart. It pumps blood through the entire body, supplying oxygen and nutrients to the cells and removing carbon dioxide and waste materials from them. This movement of blood through the entire body is called circulation of blood. Let's understand this movement. From the different body parts, deoxygenated blood is collected and brought to the heart. It enters the right atrium through blood vessels called superior and inferior vena cava. This deoxygenated blood now moves into the right ventricle. Now, in order to purify the blood, it is sent to the lungs via the pulmonary artery. In the lungs, the blood is purified, that is, carbon dioxide is removed and oxygen is added to the blood. Now, this oxygenated blood needs to be sent to all body parts. So let's take it back to the heart, through the pulmonary veins into the left atrium. From there, it flows into the left ventricle. And now, finally, through the aorta, it leaves the heart and is sent throughout the body. Thus, oxygenated blood is delivered to every cell. This completes one cycle of blood circulation. Now, deoxygenated blood is again collected, brought back to the heart, and the cycle continues. Did you know that the blood circulation between the heart and lungs is called pulmonary circulation, while the circulation between the heart and body parts is called systemic circulation? Since the blood flows twice through the heart in one circuit, it is called double circulation. Wow, I am double awesome because awesome flows constantly through me every second. You're unbelievable, some.